Yesterday we did a review of logarithms and just got the basics of them because, like I said, we're kind of skipping 3-3. But in order to move into 3-4 and in order to move into 3-5, I didn't want to just start you off cold turkey, so we did that little bit of review. And I did upload that yesterday as well. For those that weren't here, that will be on the channel as well. So, before we get started, just a little blast from the past. If I have x squared times x cubed, what would my answer be? X squared times x cubed. Why? Add exponents when multiply when what has to be true? Bases are the same. Nick, you're slipping. Thank you very much. Okay. So we add exponents when we're multiplying only if the bases are the same. All right? What about if I have x to the 5th divided by x cubed? What's my answer? X squared. Why? Subtract. Oh my gracious, I'm really getting messed up here. Subtract when dividing when bases are the same. Yesterday, we started the lesson by saying logarithms are nothing more than an exponent. Oh. Logarithms, nailed it. Logarithms are nothing more than an exponent. So wait a minute. So now I've got these exponent rules.
Do they apply for exponents?
I wonder if we can tie that in somehow into our logarithmic rules. Well, folks, let's see. Hold on tight to your britches and let's find out. Product rule, which goes along with number 1 on the little activity we did yesterday. We added and it ended up, to condense it, we ended up multiplying. If 2 factors are being multiplied in this logarithmic function here, I can separate them out using division. I can give each one of those their very own logarithmic, their very own log, and separate them out with addition. In reverse, if 2 logs, and I'm missing a main piece here, if 2 logs with the same base are being added, I can condense them using multiplication. If 2 exponents are being multiplied together with the same base, I can add their exponents. If 2 logarithms are being added together with the same base, I can multiply, condense them using multiplication. Same principle, because logarithms are exponents. Second problem, or second property, goes along with our second activity yesterday. Number 2, problem number 2. We had a subtraction. 2 natural logs were being subtracted. Same base, because they were both e. I could condense them using division. 2 logarithms with the same base. I can condense them, they're being subtracted, I can condense them using division. Or the reverse is true. You can go back and forth with these. If I've got 2 quotients that are being, or 2 factors that are being divided from one another, I can separate them out using their own logs using subtraction. Division, subtraction, multiplication, addition. The last one goes along with number 3. This exponent on our activity number 3, I've got x plus 3 quantity squared. I can bring that out and it can be multiplied by that entire log. Same principle. If there is an exponent, that exponent can be removed from the exponential, from that spot and brought out in front, and now I have a multiplication problem. So, with that being said, if I have x squared cubed, back to my exponent rules. If I have x squared cubed, what do I have? X to the sixth. A power being raised to a power. A power being raised to a power is multiplication. Same thing here. I've got a power being raised to a power because this r is in the position of what it equals to. That's the exponent. We'll talk about that here in a second. Then we have a power being raised to a power. We pull that out and I'm sorry, this is my exponent. We have that being pulled out, and then we have a multiplication problem. Okay, we're going to put all three of these into play. Here we go. So first thing, we have log base 2 of 8 times 4. This is multiplication. Multiplication, if I want to expand, if I want to rewrite this using expansion, I'm going to give each one of these its very own log. So I can rewrite that saying log, don't forget, it has to be the same base. Base 2 of 8, that multiplication becomes addition, and then I'm going to give that same log, base 2, to 4 as well. On your calculators, using your math base button or using the common log that we talked about yesterday, I want you to calculate and give me an actual value of log base 2 8 plus log base 2 4. Actually, I'm going to do something different. Left side of the room, log base 2 8 plus log base 2 4. This side of the room, right, my right side, your left side, I want you to do log base 2 of 8 times 4. So this side, do the 8 times 4. That side, do the log base 2 8 plus log base 2 4. Are you serious? You get the same thing? And what is that same thing?
Oh, I didn't. Did I just
Yeah. And the number is? Okay, you should be coming up with 5. If you did not come up with 5, double check how you input that into your calculator. Okay, good.
I forgot how to put it in my calculator.
And do you have, okay, so if you do not have an 84 plus log 8 divided by log 2, parentheses around those, plus log 4 divided by log 2. That's called converting it into common logs. If you don't have the log base button, that's how you would.
I have the log base button, but it's just not working for me.
Type it in the 2.
It just gives me an error.
Okay, I'll look at that in a second on that. Okay, second one. We have a division problem. Division means subtraction. So log base 2 of 128 minus log base 2 of 4. And again, some do the subtraction, some do the division. We should be coming up with the same answer. And that answer is 5 again.
I can guess, but
Okay? If you guys are getting errors, when we get finished with this, I'll come back and double check your input on your calculator.
I mean they're both errors, so it's
You're doing the same thing. Okay? So questions so far on either one of those. Now, here's my power rule. I've got an exponent. Where do I rewrite that and put that exponent? In the front. So I've got 2 times log base 2 of 8. 2 times log base 2 of 8. And that's exactly how you would type that into your calculator. It's going to throw you. And it is 6. Okay, that is 6.
What?
Okay? Now, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to give you about 2 minutes. And I want you to write out to the left-hand side, possibly not even that long. I'll give you 60 seconds. True or false? True or false? And if it's false, or you, however, because I'm not going to look at it, so whatever makes sense to you. True or false, and if it's false, I want you to correct it. So what's on the left, is it true that I can rewrite it the way they have it on the right-hand side? So you're looking at what's on the left. It's what's on the left. Does that equal what's on the right? Kayla?
How'd you do the last one?
You want to do the last one?
No, how'd you do the last one?
This one? Or this one up here?
That one.
This exponent from the quotient rule says, or the power rule, that I can bring my
I know that, but like, how'd you get 6?
Oh.
How'd you do that?
2 times log base 2 of 8. Listen to Maggie. She's got it going. Okay, for video purposes, we're going to keep going because, you know, that's kind of how they do it in, you know, real life. If you're doing a live TV show, sometimes it's not as real as you think it is. So, because you got to keep going on that. How do I know that? I don't. I'm just kind of making that up. So anyway, number 1, natural log, x plus 2. Can I break that into 2 different natural logs the way that's written? No. So that is false. And if I'm looking strictly at what's on the left, that can't be simplified. If I'm strictly looking at what's on the left, that can't be simplified. If I wanted to simplify it to the way it is on the right, what would have to happen between the x and that 2? It would have to be multiplied. Number 2, is that a true statement?
No.
It is false. Because if I want to rewrite that, expanding it, log base 3 of,
7.
log base 3 of, perfect.
Or could you change the first one to x raised to the 7?
Except I want you to read it in terms of what's on the left.
Okay.
But to answer your question, AJ, yes. This would be log base 3 of x to the 7th. Yep. But we're looking at in terms of these right here. So number 3, true or false?
True.
True. Because 5 is being multiplied by x, and so they each get their own log base 2, same base, and I can use addition on that. Number 4, true or false?
True.
True. I've got an addition, natural log, and they each can get their own natural log using subtraction. Number 5, true or false?
False.
To rewrite that according to what's on the left, I would have log base x minus, and I said log base x. I mispronounced that. It's log, common log, x minus common log 4. Because what's my base when no base is written? 10. Perfect. Number 6, true or false? It is true. Because there's my exponent. The exponent goes out in front according to the product rule. Number 7, true or false? False. And again, I should be using the product rule on that since I have the exponent. So that is 2 log base 5 of x. And number 8, true or false? True. Good job. Any questions on 1 through 8 as we go through those? Okay. Then moving right along, I've got 2 down here at the bottom that I want you to rewrite, expand them. And I'm going to use the word, this says rewrite as a sum or difference of logs. Also, I want you to know that you'll also be heard to expand this logarithm. So expand and condense are also words that you're going to need to get to understand when asked. Okay, so this is expand. So take about 30 seconds. Take about 30 seconds writing that as an expansion. Am I going to be adding or subtracting? Okay. What's my base on that log? Do I have to write that? So log 8, log x.
4 log.
4 log.
Awesome. I've got that exponent. So the 4 comes out. So 4 log e. 4 log e. 4 log y. Okay. The second one, natural log, square root, x squared plus 5 divided by, and that square root just goes over that binomial of x squared plus 5 divided by x. But real quick, before we do that, how do I write the square root of x as an exponential? You're exactly right. So the square root, anytime that you see a radical, please understand that you also have an exponent going on. Okay, you've got an exponential function there as well. So therefore, well, not an exponential function, but I've got an exponent in that spot. So I can rewrite this as natural log x squared plus 5 raised to the 1/2 divided by x. That's how it's written. Okay? So I have, how do I start this off? I've got division, so therefore I'm going to be using subtraction. But this 1/2 goes where? Out in front. So I've got 1/2 times natural log x squared plus 5 minus natural log x. And then the last, not the last two, but the next two, I'm going to rewrite, and I'm going to call this condensing because I'm making it smaller. I'm going from 2 natural logs down to 1. I'm going from 2 logarithms down to 1, so that's called a condensing. I'm going to be condensing those. This is subtraction, so I'll end up divide. Good job. This 3's out in front. So it becomes x cubed divided by 2. Notice where the division symbol is located. The natural log is not under the division symbol or over the division symbol, just the x cubed and the 2. So it's the natural log of that.
Why is there a natural log in the bottom fraction?
Because we're condensing it. We're going from 2 natural logs to 1. Because that's the purpose of what we're doing, is we're simplifying it. We're trying to make it smaller. Okay, the bottom part. The top part is where we expanded and we made it larger by giving each one of those terms its own log or natural log. Okay? And then my last one, if I really wanted this to be expanded fully to start with, where would this 5 have been located? Out in front. Okay, so it kind of saved you on that. So I know I'm going to be writing it in terms of natural log, so I'll go ahead and write down my natural log. This 2 is division. So what's going to be in my numerator? And in the denominator? It's the quantity of xy being squared. Making sure that that square is with the quantity of x and y. Okay, questions on rewriting as single or rewriting expanding it? Okay, this change of base at the bottom we've already talked about, and this has been directed to those with a calculator that would be like a TI-83, a little bit older model, on how to write, how to type in a logarithm other than base 10 into your calculator if you don't have that change of base function programmed into your calculator. This is what we're using, the change of base formula. So basically what it's saying is, and I'm going to give you kind of an example out here, that if I have log base 2 of 3, okay, if I've got log base 2 of 3, so anything other than base 10, I can rewrite anything that does not have a base 10 using a base 10 logarithm. And a base 10 logarithm is called your common log. anytime that you have a common log, you can rewrite it using a natural log. And I'll show you that here in a second. So by using the change of base, I'm saying log 3 over log 2. And again, yesterday, once a base, always a base. Once a base, always a base. So the base of the logarithm becomes the base of the fraction. It's in the denominator. Okay, so that's how you can remember that. So now there's no base here except for base 10. So I have rewritten this logarithm using the change of base formula using common logs. So in this here, b can be any number, but a in this situation is 10. A is my common log. So real quick, log base 3 of 17, rewrite it using a common log. This is a gimme. This I would consider to be the gimme on a quiz, on this quiz, okay? Pretty straightforward, pretty simple. And then I want you to actually calculate that out using the common logs, okay? Using the log on the front of your calculator. So take log 17 divided by log 3 and tell me what you get. Okay, rounded to the hundredths, we get about 2.58. It's an approximate. We had to round that up. That's an approximate. Now play with me here for a second. I'm in a...
That was 1.55.
I need to look. Are you in,
Well, you
I'll have to look at yours.
Oh, is that radian degree mess with that too?
I'll look at it and see on that, because it really shouldn't on this. Log 17 divided by log 3, these are both common logs. Now I want you to use the natural log and take natural log 17 divided by natural log 3. And what do you get? Same thing. So please hear this. If you are in using a common log, log base 10, you can rewrite that using a natural log, because the natural log has base e. Common log and natural log can be interchanged when they're written. Now this log base 2, or written as log base 3, I can't say natural log of 17 and get the same thing. It has to be converted to common logs first. All right? Do the same thing here. You get log 78 divided by log 5. And what answer do you get for that? Say that again. 2.78? 2.71. And then if I would convert that into a natural log, I should have the same thing.